All right, so first section of the day comes from chapter 2. We're going to talk about circles and real basic idea of just general information about circles. And the first thing is the equation of a circle. The equation of a circle is similar to the vertex form from a quadratic that we talked about on Tuesday, where you've got this h and k that's put in there. H and K are the center of the circle. So definition in geometry class and is the definition of a circle is all the points that are equidistant from a center point. So the center as it is at the ordered pair HK. Notice how both of these are in parentheses and it's a minus sign in there. So you're always going to take the opposite of what's in there. So if it's negative, if it's x minus 3 for the H part, you're going to pull out a positive 3. If it's x plus 3, you're going to pull out a negative 3. So you always take the opposite. Same thing on the K here. The R is the radius of the circle. And the radius of a circle, how far from the center to the edge of the circle. So that it's the radius halfway across. And notice that that's R squared. So if that's a 16 out here, you know that the radius is 4. And that's how we're going to work that. So really, like I said, we don't get too strenuous when we're talking about circles in 100, and we don't actually talk about them very much at all in 110. But we do just a little bit with them. So one of the things that the skills that you need to be able to do is to find the center and radius given an equation. So here's our equation: x minus 5 squared plus y minus 3 squared equals 16. So this is a good one to start off with. So all we're doing is finding the center. So we're looking for an ordered pair, and then the radius. So we're looking for a number there. Okay. So the center is always going to be, the form is x minus h squared plus y minus k squared equals r squared. So h in this case is going to be positive 5. K in this case is going to be positive 3. Always going to take, it's a minus sign in there, take a positive out. If it's a plus sign inside, take a negative out. The radius, that 16 over there, is r squared. So what we want to do is take the square root of 16, which we know is 4. So the radius is 4, and the center is at 5, 3. That's what we're finding out of that equation, just pulling out the center and the radius. So knowing that form and then pulling some stuff out of that. So let's do the same thing for example B. Let's say we had x plus 3 squared plus y minus 4 squared is equal to, let's do 32, something like that. Again, we're just finding the center and the radius. The center, we're going to take the ordered pair out of there. So opposite of plus 3 would be a minus 3. Opposite of minus 4 would be a positive 4. So the center is going to be at negative 3, positive 4. Radius a little tougher on this one because 32 doesn't have a good square root. So we're going to do that simplifying of the square root idea that we did before with the factor tree. So we're always going to find the radius, you're always going to take the square root of this number that's on the end. So 32, that'd be 8 times 4. And that's 4 times 2, 2 and 2, 2 and 2. So on this we have a pair, 2 pairs of 2s, and then a 2 left over. So that's going to be 2 times 2 radical 2, which is 4 radical 2, or 4 square root of 2. As the the radius of that. So center at -3,4, and then a radius of 4 square root of 2. If you were having to graph this, won't do that very much at all in there. You would probably want a decimal equivalent for the square root of 32. Square root of 32 as a decimal, 5.66. So if you were going to graph that, you would put your center at this point, and then you'd go 5.5 blocks out, or a little more than 5.5 out, around there. Again, we don't do a lot of graphing with circles in this course. We mainly work with the equation. Okay, out of that. Let's do another one of those. So we had x squared plus y plus 7 squared equals, let's do 12. So this one's looks a little different, you know, and again, we're still just finding the center and the radius. The center, well, there's no parentheses or anything in there. So when you see that, you need to think, hey, that's just this. X minus 0 would be the same thing as x, right? Because you subtract 0 from something, it doesn't change it, right? So x squared is the same thing as x minus 0 squared. So that means the center has an x value of a 0 and a y value of what? -7. Good job. Yeah. So it's not incredibly strenuous stuff here. And then we're going to take the square root of 12, and we'd break that down with the factor tree like we did. 6 times 2, 3 times 2. There's a pair of 2's and a 3 left over. That's going to be 2 square root of 3, which if we did a decimal approximation for that, I'll just type in the square root of 12, and it's 3.46. Always going to take the square root of that number on the end. All right. The other thing that we do with circles is to go the other direction and take given a center and a radius, build the equation from that. So it's just the synthesize, create an equation. So we're going to do that. So let's write the equation of a circle with center at 6, 8 with a radius of 7. Okay. So again, we got to know the formula: x minus h squared plus y minus k equals the radius squared. Okay. So real easy thing here. It's just plugging stuff in there, and you really don't even have to work much out. So the x minus 6 squared, and then y minus 8 squared, and then it tells us that the radius is 7, so we're going to put 7 squared there. But we know 7 squared works out to a number, right? We can square 7. 7 times 7 be 49. So the final answer would be x minus 6 squared plus y minus 8 squared equals 49. That would be the final answer for that one. Don't overthink it. It's really not, any more difficult than what we're doing here. So don't overthink this stuff with circles. A lot of exponents and things going on there, but nothing really just extremely hard here. Let's do the same thing. Let's have one that has a center at -13, 5 with a radius of 2 square root of 2. A little bit more difficult because it's got the weird looking radius, but don't overthink it. Just we're going to take that form, x minus h squared plus y minus k squared equals r squared. And we're going to plug that stuff in. So when I plug in a negative 13 in here for h, that's going to make that become x what 13? Positive, yeah, plus because of the double negative out of that. So, and then the 5, it doesn't change the sign because it's a positive 5, so it stays there. And then the radius, this is the hard part of this one, is the radius, because you've got to square 2 radical 2. Don't overthink it. I'm just going to go to my calculator, and I'm on, in parentheses, put 2 square root of 2, and then press the right arrow key to get out of the parentheses. Close up those parentheses and square it. And get an 8. So final answer, we need to change that to an 8 there. And the rest of it is the same. So don't overthink this. It really is just straightforward, that stuff. I'm not, we're not asking you to do incredibly crazy things with equations of circles. All right. Really, that's all of that section about equations of circles. So nothing major to that. Just straight up plugging into the form that you've got there. So make sure you have that form handy when you're doing labs and quizzes for that, and you'll be okay. All right. Well, let's go ahead and jump into the polynomial stuff. We've got 2 different types of division we're going to do today. One is not so fun looking. It's not extremely difficult, but it's not fun looking. It looks really intimidating once you see a problem done that way. But if you'll take it one step at a time, it's not too bad. And that is from going back to section R3 and going into polynomial long division. So polynomial long division. It's probably been a while since you've done long division by hand without a calculator or anything like that. So let's go over a problem about how to do long division with numbers first. And we're going to use that to kind of help us think about doing long division with polynomials, okay? So let's take a number like 7 divided into something like 54. Okay. And when you did long division in elementary school with this, that's where probably the last time you did long division without a calculator by hand. So we looked at that 7 in the front and we tried to say, okay, how many times does 7 go into 5? Well, it doesn't, right? So then we think, okay, well, how many times does 7 go into 54? And we think about our multiples of 7. So 7 times, we'll jump to 7 times 3 is 21. So definitely bigger than that. 7 times 3 is 21. 7 times 4 would be 28. 7 times 5 is 35. So we're getting closer. 7 times 6 is 42. That's closer. 7 times 7 is 49. And 7 times 8 is 56. So 56 is too big, right? So we're going to go 7 times 7. So we're going to put a 7 up here. And then we multiply 7 times 7 and put that down here. And then we subtract that from the number, right? And 54 minus 49 would be 5. And then remember, if we were going to do this in decimals, we would put a decimal point right there and keep going. Okay, we're not going to do that. what was the way you did it before you started doing decimals? Y'all remember doing that R5? Y'all remember, it's been a while since you've seen that, but you probably have seen 7R5, that there's a remainder of 5. That's what that meant. So what we're going to be doing is doing that with polynomials, and we can have a remainder with polynomials. A lot of times when we write remainders in elementary school, you did this with fractions. A lot of times you would have 54 over 7, and you would write that as a mixed number. You remember doing that? That it's 7 and 5/7. Well, that notation of a mixed number is really 7 plus 5 over 7. That's what that notation means. Nobody ever told me that when I was in elementary school. It probably would have made more sense to me if they did. But that's what that notation says. It's 7 whole pieces and then 5/7 of another piece added to it. That's what that means. And that's the same thing as this. So this is the way that we write remainders and polynomial quotients when we do polynomial division, is with the plus sign in between. All of these ways are ways of writing answers with division. This way is the way we do it with polynomials, with the plus sign in between there. We'll see as we do some of these. When they've got a remainder, we're just going to add it to the end and put it as a fraction over what we divided by. Okay, so it's not, it looks like it's going to be complicated, but if it's one step at a time, it's not too bad. All right, so let's look at an example of polynomial division, and we're going to do long division first, and then we'll do what's called synthetic division, which is a better way for certain kinds of problems that you can use synthetic division on. So we got to be able to do long division, though, for some stuff that you're going to see in 110. There's a specific skill that we need long division for that. So that's one of the reasons we do that. And it also kind of helps introduce the idea of division for synthetic divisions as well. So let's take a polynomial division problem. It would be something like this: x to the third power plus 6x squared minus 8x plus 10 divided by x plus 3. So they would present the problem sometimes like this as just a written out division problem. One of the things you want to keep in mind is, remember that everything needs to be in descending order. Start with the highest power of x and go down. That needs to be for what's called, this is your dividend, and this is your divisor. The dividend is what you're dividing into. The divisor is what you're dividing by. Okay. Dividend and divisor both need to be in descending order. So start with the highest power of x and go down. These are both in that order: x cubed, then x squared, then x, then plain numbers. X to the first power, plain number. Those are both in the right order. You want them in that order. You also, if there's a missing piece kind of in the middle, you've got to put a representative for that. And we'll see that as we go through some examples about what you've got to do for that. So let's set up the long division for this. So we're going to set it up in the same kind of format as we did that number problem earlier. So we're going to put the divisor out in front, long division symbol, and then put that polynomial x to the third power plus 6x squared minus 8x plus 10 in there. Remember, it's got to be in order, and if there's a missing piece in the middle, we're going to put a 0 in its place, just so we've got a representative from everybody, okay? And what you want to do then, the way that you look for this is you look at this front piece. The plus 3 that's in there doesn't really matter when you go to do your division. The part that's in the front, the leading term is what it's called, is what matters, okay? So we're going to look here and we're going to say, okay, how many times, or what times x would get me x to the third power? X squared, that's right. So I'm going to put an x squared up top, okay? The next thing that we did up here when we put that number up top is we multiplied 7 times 7 and got the 49. We're going to do the same thing with the polynomial, but we're going to multiply x squared times x plus 3. So it's like distributive property out of that. So x squared times x plus x is x to the third power. X squared times 3 would be 3x squared. And then the next thing we did was subtracted that from what's above it. So we're going to subtract all of that. So put it in parentheses and subtract. Okay. X cubed minus x cubed, they cancel each other out. That's what we want to happen, right? And then 6x squared minus 3x squared. 6x squared minus 3x squared would be 3x squared, right? Now in long division, the next thing that you would do if it were numbers would bring the next digit down, right? Well, we're going to bring the next term down to minus 8x. So we're going to drop the minus 8x down here. So that's just what we're doing. The plus 10 is still there. We'll use it later, okay? Now, the next step, our lights went off. I was waving my arms and everything. All right, the next step is, again, start with the front piece. Look at the x. But we're going to say, what times x will get me 3x squared? What times x gets me 3x squared? 3x, that's right. So I'm going to put a positive 3x up here. I'm going to change colors on my thing so we can, it's the next operation. I'm doing in red. So plus 3x. So plus 3x times x is 3x squared. Positive 3x times positive 3 would be positive 9x. So I'm just distributing that 3x to the x plus 3, to the divisor in front. And again, the next step in long division is once you multiply, you subtract. So we're subtracting all of that from what's above it. 3x squared minus 3x squared. That cancels each other out, doesn't it? It's what we want to happen every time. If that doesn't happen, something's not going right. You're not getting the right things there, okay? And then we're saying negative 8x minus 9x. Negative 8 minus 9. That'd be negative 17x. Okay. All right, the next step is to pull down the next term. So plus 10 comes down. All right. Can we multiply something times x and get negative 17x? What times x would get me negative 17x? Yeah, negative 17. Yeah, just the number that's in front. If we multiply negative 17 times x, that's negative 17x. Negative 17 times positive 3 would be negative 51. Parentheses, subtract. Negative 17 minus negative 17, that's going to cancel each other out. That's what we want to happen. And then we've got 10 minus negative 51. Double negative there, so that's going to be 10 plus 51, which is 61. My division is finished now, because if I multiply something times this x in the front, there's no way that I'll get something without an x, right? So that's how I know I'm done, is that what I've got underneath doesn't have this front term on it. Okay, so that's how I know I'm finished. Now, so that means 61 is my remainder. The way we're going to write our answer is we take this stuff up top, x squared plus 3x minus 17. That's this stuff up here. And then we're going to put a plus sign the remainder, 61, over the divisor, x plus 3. That's the answer to that problem. A lot of steps, a lot of places that sign mistakes could get you. But one step at a time, it's just distributed property is all it is. Once distributed property, then a subtraction. Distributed property, then a subtraction. Distributed property, then a subtraction. That's what you're going to do every time with this. We're going to do several examples here, so we'll get some practice at it. It just takes practice. It's not anything I expect anybody to be able to do first go round. So let's take this one. Let's take 4m to the third plus 5m minus 8m squared plus 6 divided by 2m minus 1. Okay. All right, now let's set it up to do our division with. So our divisor goes on the outside, 2m minus 1. On the inside, we need the dividend. But what do we notice about this dividend right here in the middle? It's not in the right order. So we got to just rearrange it. That's all we got to do. The biggest exponent on the variable is a 3, so we're going to put that part first. 4m to the third. The next piece should be what? The 8m squared. And it's a negative 8m, so we're going to put a minus 8m squared. And then the plus 5m. So we're just swapping the order of those two pieces so that we get it in descending order. And then the plus 6 is on the end there. All right. So this one, only difference really is we had to put it in the right order, and there's a number in front of this first piece. Again, when you do the long division, you look at that piece in the front. What times 2m gets me 4m to the third? 2m squared. So above the m squareds, I'm going to put 2m squareds. Okay. Then what's the next step? Well, we gotta multiply it out, distribute it across there. And so 2m squared times 2m would be 4m to the third. 2m squared times negative 1 would be negative 2m squared. Parentheses and subtract. All right. So subtracting those, the m cubes, those should cancel out every time. If they don't, you're not got the right number up there. Okay. So those cancel each other out. Negative 8 minus negative 2. Be negative 6m squared. Bring down the next term. Again, go back to the front. What times the 2 gets me the negative 6m squared? Or 2m times what gets me negative 6m squared? Positive or negative 3? It should be a negative 3 because we want it to be a negative 6 when we multiply it out. So negative 3 times 2 is a negative 6m squared. And then negative 3m times a negative 1 would be a positive 3m. Parentheses, subtract. Okay. Again, that front piece there, the 6m squareds, if they don't cancel out, you got the wrong number up there. Okay, so they cancel there. 5 minus 3 would be 2m. And then we bring down the next term. And then just go from there. All right. Now, the next thing would be look at the front again, the 2m. What times it gets me 2m? Yeah, positive 1. Just regular old 1 goes up there. So plus 1. We distribute. Plus 1 times 2m, that's 2m. Plus 1 times negative 1. That's a negative 1. So we get that same piece back. And then we're parentheses, subtract. Okay. Again, those pieces there in the front, they got to cancel out. If they don't, something's wrong. You got the wrong number, wrong number up there. And then 6 minus negative 1, that'd be 6 plus 1, which is 7. And I know that is my remainder because there's nothing times 2m that'll get me a plain 7 back. Because if I multiply something times 2m, I'm gonna have an m on it no matter what. All right. So this is my remainder. And again, remember the way we're going to write our answers. You're going to have the stuff up top, 2m squared minus 3m plus 1 plus the remainder over the divisor. Okay. Fun stuff. I'll be honest. Synthetic division will seem so easy once we've done all this because there's tons of operations here. There's a lot of operations in synthetic, but there's no letters in there, so it makes it a lot easier without the letters. You just got to remember where to put them back at. So let's do another problem with long division here and see if we can. I think we feel a little more confident in it right now. Let's see if we can get a little bit better. Sorry, I started writing it in long division form before I wrote the problem. 3x to the third minus 2x squared minus 150 divided by x squared minus 4. Okay, so we have look at the terms here. The dividend, we've got x cubed, x squared, and then a plain number. Here we got x squared and then a plain number. So they're in descending order, but when we go to write up our problem, what do we notice about both of them? They're missing a piece, right? We get cubed, squared. There should be a piece that has a plain x on it, but it doesn't have it. Okay, same thing's happening here on the divisor. We've got a x squared. We don't have a plain x in there. So when we go to write up our problem in long division, we're going to set it up x squared, and we're going to put a plus 0x in the middle, and then the minus 4. And then on the dividend, the stuff underneath there, we're going to have 3x cubed minus 2x squared. And then because we don't have a plain x, we're going to put a plus 0x in there, minus 150. Okay. Adding that piece in there helps line everything up. It's not that you can't do it without it, but it sure makes it a lot more confusing about where to put things when you don't have it in there. I like having it in there because it gives me a column for every type of thing that I could get, because I've got an x cubed column, I've got an x squared column, I've got a plain x column, and then I've got a numbers column. So that's always, notice on all these problems that the first two problems we've done, I've got an x squared or an m squared column, a plain m column, plain numbers column. Go back to example A. We had an x cubed, an x squared, plain x's, plain number. organization is always a key to good mathematics, is being organized with your work. So when we're doing this, having that piece in there helps us organize it so that when we multiply stuff out, we've got a place to put things. Okay? All right. So again, we're going to look at the front piece. That's the only part that matters about all this stuff on the divisor, the front leading term. Okay, so x squared times what gets me 3x cubed? 3x. All right, so 3x is a plain x, so that's going to go over the top of the 0x. So that's where I put it. Helps keep me organized by putting it there. It's not necessarily, you won't see everybody. If you Google somebody else doing long division with polynomials, they may put their 3x up here in the front. I don't do it that way. I like to organize it a little bit better. All right, and then we distribute that across this polynomial. So 3x times x squared, that's the 3x cubed we were hoping for. 3x times 0x, that'd be plus 0x squared. 3x times negative 4, be negative 12x. Parentheses and subtract. Well, x cubes, bye-bye. Negative 2x squared minus 0. That's still negative 2x squared. 0 minus negative 12. That's a positive 12. Double negative, but turned it to a plus 12. And then we're going to bring down the minus 150. This problem's going to be a little shorter because, look how far we got. We already got to the last term. So it's going to just be a two-step thing here. So again, we're looking at the front piece of each of these. What times x squared gets me negative 2x squared? Yeah, just a negative 2. That's right. So negative 2 times x squared is negative 2x squared. Negative 2 times 0x would be 0x. Negative 2 times negative 4 would be positive 8. Parentheses, subtract. X squareds go away. That's what we wanted to happen. 12 minus 0, still 12x. Negative 150 minus 8 will be more negative, so that'd be negative 158. Now, here's how I know that that's the remainder. The leading term's x squared. If I multiply something times x squared, it's going to have at least x squared on it, right? So the 12x is smaller. So that's how I know I'm done. I can't go any further because nothing times x squared will get me a plain x back. It's going to get me at least x squared back. So I know that this is the remainder. Okay. Again, remainder. I just put an R there. Okay. And again, we write our answer. 3x minus 2 plus 12x minus 158. And I'm just going to shorten up and go to the original divisor, which was x squared minus 4, just to shorten it up a little bit. Long division, we don't have to do it a lot in 100. It's a skill that we've got to have for some stuff that we'll do in 110. So it's important to kind of start with it, but it also helps us get our division juices flowing for synthetic division, which is what we'll use the most of in 100. Okay, so we're going to do synthetic division next with this. Any questions about long division? It's a lot of operations, a lot of signs to watch out for. Be very careful. Don't get in a rush when you're doing the long division problems, because if you do, you're going to make a sign mistake. All right. All right. Well, do y'all need a break, or you just want to go on through? Because we're going to get done pretty early today. So if you want to just go on through, we can, or if you want to take a short break, we can do that too. All right. I don't hear anything, so I'm going to keep going because I'd like to get done today too. So let's just continue. This is jumping from synthetic. We're going to get into synthetic division and the factor and remainder theorem. So we're gonna do some this thing called synthetic division with this, and this comes from chapter 3, section 2. Synthetic division. You might hear it called synthetic substitution. And then we'll talk about the factor and remainder theorems. With that, okay, so synthetic division and the factor and remainder theorem here, and we're gonna learn the skill today and talk about how to do the actual work that's involved, and then Tuesday we'll take this skill and use it to help us solve polynomials or find their x-intercepts with polynomials and do some stuff with polynomials out of this. So synthetic division is what we'll start with. And one thing that you've got to know with synthetic division is that it can, or synthetic division can be used when the divisor, what you're dividing by, is linear. And that means, for example, something like x minus 5, 3x plus 7, 2m minus 1. That was one we had earlier. Those are linear because the highest exponent is a 1. You don't have a plain x. You don't have x squared or anything like that in what you're dividing by. Okay, so synthetic division can be used when your divisor is linear. So when you're doing problems that are just asking you to divide, and that's the only instructions they give you, what you've got to be able to recognize is when can I use synthetic division and when do I have to do long division? Because I don't know very many people that once they learn synthetic division will continue to use long division because when you can use synthetic, it's so much quicker and easier than long division. You want to use synthetic as much as possible. So we're gonna talk about that. And when you can use that is when your divisor is linear. So let's start with a nice problem here. Let's take 5x to the third minus 6x squared minus 28x minus 2 divided by x plus 2. Okay. So synthetic division, the way you you can use that on this is the divisor here is linear. It's got a plain x and a number. Okay. Anytime the divisor is linear, you can use it to use synthetic division. And what you want to do to start your synthetic division is make this little L-shaped. And then I put a little shelf on it. So if you're using notebook paper, it usually just takes 2 lines of it. And you got a top line, a second line, and then your answers are going to go underneath. So make this little shape here. It's just like a laying down L. All right. And then what's going to go up here on the top row inside here are the coefficients of your dividend. So what you're dividing into, the coefficients. So you would have a 5, a negative 6, a negative 28, and a negative 2. So we're not putting the letters there. We're just putting the numbers. So already it looks a little easier because you don't have all the letters there. Okay. Now, if there were a missing piece, you would put a 0 in its place, just like we did with the long division. So that's the continuation of that. Now, the next thing we need is the number that goes on the shelf. Okay. To get the number on the shelf, you want to set the divisor equal to 0. And solve. Okay, so in our case, we're setting x plus 2 equal to 0 and getting x by itself. -2 is what goes on the shelf up here. That's how you're going to get that shelf number. Okay, it's always going to be the opposite, but I always say set the divisor equal to 0 and solve it, because sometimes it might be a fraction if there were a number in front of the x there. So you've got to set it equal to 0 and solve it is basically, it's taking the opposite of it. But, all right. Now, the way synthetic division works, it's always, instead of, in long division, it was multiply and then subtract. Synthetic division is multiply, then add. Okay. Multiply, then add. So what we're going to do is the first step is to drop the 5 down. Whatever that first term is, you're going to drop that number down to the front every time. That never changes. Okay. And then the next step is multiply this number down here times the -2 times the shelf. 5 times -2, -10. Add -6 plus -10 would be -16. Multiply -16 times the number on the shelf. -16 times -2, +32. And then we're going to add 32, -28 plus 32, be 4, right? Multiply 4 times -2, -8. Add -2 plus -8 is -10. This number right there, that -10, that is your remainder. Okay. When you do synthetic division, it always takes the polynomial you divide it into and reduces its power by 1. Okay, so we started with an x cubed problem. So when we do a synthetic division by a linear divisor, it's going to take it from an x cubed to an x squared. So what you do then is you just take these numbers and you put them in front of an x squared minus 16x plus 4, and then we're going to do plus -10 over x plus 2. That always, we started with x cubed, then the first term is going to have an x squared. If you started with x to the 4th, the first term is going to be an x cubed. If you started with an x to the 5th power, the first term is going to be 1 less than that. Always 1 less. And then you just descend down. So that's one of the important parts about having it in descending order, is if you don't have it in descending order, then you're going to have some stuff out of whack when you go to write your answer. Okay. All right, so there's synthetic division, multiply and add. So a lot less room for error when we're adding than there is when you're subtracting, because when you're subtracting, you get all these double negatives and things that you got to deal with. So that makes that more difficult. So synthetic division, I think, is much easier. You don't have to deal with all the letters. There's not nearly as long a multiplication problem to do, and there's no subtraction. So it's a lot easier to get that. But it only works if what you're dividing by is a linear piece. Okay, so it's got to have just a plain x in it. It can't have x squared or x cubed or anything in it. If it's got those in it, you've got to use long division. Okay, let's look at another one. Let's say they present the problem to us like this: -x to the 4th plus 3x squared minus 4x minus 5. And they write it like this, which is kind of sneaky. All right. So that's a division problem. It looks like a fraction, but it's a division problem. It's a division problem with this is your dividend and this is your divisor. Okay. They just wrote it as a fraction. So it's the same thing. So when we do that, we're going to, we got a divisor that's an x plus 3. That's a plain x and a number. So that tells me, hey, that's linear. I can do that with synthetic division. And anytime synthetic division is my option, I'm going to use it. Okay. I'm going to set it up with synthetic division. So I'm gonna put the coefficients on the top row. So I got a -1 for x to the 4th power, but that's in descending order. But what's missing? X cubed. So I've got to put a 0 in its place. And then the 3 for the x squared, the -4 for the x, and the -5 for the plain numbers. Okay. And you space them out ever how you need to there, just to keep yourself organized. Now I need to know what goes on the shelf. How do I find that? Set x plus 3 equal to 0. Subtract 3. X is equal to -3. So -3 goes on the shelf. That's how I know that. And then go from there. Let's drop that down. That's a -1. And then multiply. -1 times -3. +3. Add. Get back a +3. Multiply. 3 times -3. -9. Add. Be -6. Multiply. -6 times -3. It's going to be +18. Add those together. -4 plus +18. 14. And we got to multiply. 14 times -3. -42. And then -42 and -5 added together would be -47. And again, that's our remainder out of that. It's -47. So what do we write as the quotient? The -1 x to the what power? So what does this become? We started with x to the 4th. Synthetic takes it down by 1 power. So it'll be x to the 3rd. And then that's a +3x squared minus 6x plus 14 plus -47 over x plus 3. Another way that this could be written is taking the x plus 3 in parentheses and then putting the -x cubed plus 3x squared minus 6x plus 14 and then -47. That's also an option. These two mean the same thing. I like this way better. That's my preference. This way is showing that the divisor was x plus 3, and it's more of a factoring type method of doing that. But like I said, I prefer the top one because that's how we do long division problems. So I like doing that. The synthetic one's the same way. So don't overthink that too much there. But so synthetic division, that's the tool we're going to be using to break down some polynomials. So what we're going to do is use that to talk about the factor and remainder theorems. Okay. And we're going to talk about those together. They're two separate theorems, but they work together in dealing with polynomials, factor and remainder theorems. what they say, I'm just giving you the working parts of it here. Kind of wordy theorems if you look them up, but I'm just going to give you what they say. They say if the remainder is 0, that's the important part, then the divisor is a factor of the polynomial. The factor is also related to the x-intercept for the polynomial. So when we if we found out that, say x minus 1 is a factor, then we know that -1 is also an x-intercept out of that. And we'll talk about that as we go through some examples here. So we're going to take a polynomial and then break it down and verify if something is a factor or of that polynomial. And if it is, then we know some things about it. We know that it's a factor. We also know that it has an x-intercept at that place. So we're going to look at doing a few examples of those types of things. So good news is today you'll get all the information, given to you as far as if it's to try. Tuesday, we'll have to start working on how to come up with those numbers on our own. Okay, so that's the difference. Today's more of a skill type thing, and then Tuesday we'll work on working on building it from the ground up idea. So let's take an example. So we're going to decide if the given value is a 0 of the polynomial and when I say 0, that's the same thing as an x-intercept and a factor. Okay, so example C. Let's take a polynomial. F of x is equal to x to the third power minus 4x squared plus 9x minus 6. And then that's a semicolon there. Is k equals 1 a 0. Same question would be, is x minus 1 a factor? Those two ask you to do the exact same work. Okay? These two questions ask you to do the same work. They're worded differently, but they're asking you to use the same skill. Okay? So here's the skill that we're going to use. We're going to use synthetic division because they want to know, is 1 a 0? So if I can take 1 and put it on the shelf here and run it through synthetic division for this polynomial, 1, -4, 9, -6. So I'm just setting up synthetic division for this polynomial by the value they gave me. They gave me a value, is 1 0 of this? Or they might ask it in this way, is x minus 1 a factor? X minus 1 equal to 0 would be X equals 1. That's why we know those are the exact same question. Okay. Now, we're just going to run synthetic division with that. If we get a 0 in that spot right there, then the answer is yes. If we get anything else, then it's no. Okay. All right. So let's do that. Let's run it through. So we drop the 1 down, multiply, and add. -3, 6. 6 times 1 is 6. -6 plus 6 is 0. That 0 right there, that tells us that yes, it is a factor or it is a 0. And it also tells us that x minus 1 is a factor of f of x. Where we're headed with this is actually taking that polynomial and factoring it. Okay, so if x minus 1 is a factor, then what's left here, x squared minus 3x plus 6, is the other half or other part of this polynomial. So when we can do that synthetic division and get a 0 there, it verifies that this is a factor, which means we can factor that larger polynomial. And that's where we're headed with this over the next couple of days, today and Tuesday. Okay, so we're kind of starting to break down a polynomial based on it being a factor or not. If it's not a factor, we can't do that. So it doesn't help us any. Okay, so we're looking to verify if it's a factor or not, and then we're gonna go ahead and do this step and get started on the factoring part of it. And then if we were to try to go further, we would try to factor this quadratic here with the x method if we were going to do that further. This one doesn't factor any further than that because we didn't want it to. So, and numbers don't work. Nothing multiplies to be 6, and it has to be -3. So let's look at another example. Let's say here's our polynomial. We'll just get a different one. X to the 4th power minus 2x to the 3rd power plus 4x squared plus 2x minus 5. That's the polynomial we're checking in. Is x plus 4 a factor? That's one way they could ask that question. They could say, is k equals -4 a 0? Both of those questions ask the exact same thing of you to do. They want you to do the exact same work. Okay. The reason is because when we set x plus 4 equal to 0 and solve it, we get -4. And we know that when we do synthetic division, that -4 is what's going to go on our shelf up here. And if we get a remainder of 0, then we know -4 is an x-intercept. We know x plus 4 is a factor of that big polynomial. If we get anything other than 0, then we know it's not, and it didn't help us any. So we're going to have 1, -2, 4, 2, -5. Drop the 1 down, multiply. Adds to be -6. -2 plus -4 is -6. Multiply. +24. Add. 28. Multiply. Doesn't look very promising here, but go ahead and finish it out and see. -4 times 28. I don't know my 28's times tables. Negative 112. Add, I can do that. That's negative 110. Multiply. Definitely know that that's not going to be positive 5, but I'm just going to go ahead and get the 440. And when you add those together, you get 435. That right there. Doesn't matter that it's 435 other than that tells us this is not a factor. And negative 4 is not a 0 or x-intercept. That's what that tells us. Okay? That does not factor that polynomial in for us. In fact, this is all it does. It just makes it look worse. X plus 4. And then we could go x cubed minus 6x squared plus 28x minus 110 plus 435. That doesn't really help us any. It doesn't get the polynomial to work out any better. So that we're looking to see, is it a factor? Is it not? If it is, we're going to do some stuff. If it isn't, then how much we can do. Let's take another polynomial. F of x is equal to x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5 is k equals negative 1, a 0. The other question that asks you to do the same thing is x plus 1 a factor. Same question or same work. It's a different way of asking the question. So set up your synthetic division. Negative 1 on the shelf. 1, negative 2, 4, 2, negative 5. Drop the 1 down, multiply. Add. Negative 3 times negative 1 is positive 3. Add. Multiply. Negative 7. Add. Negative 5. Negative 5 times negative 1 is positive 5. And what do you know? Get a 0 there. So this is k equals negative 1 is a 0 or is an x-intercept, same thing. Or x plus 1 is a factor. And because it's a factor, I could rewrite this problem as x plus 1, and then the quotient of the answer here, this part would be x to the 3rd power minus 3x squared plus 7x minus 5. And technically there's a plus 0 out there, but you know, anytime we're adding 0, we usually don't write it. This part here is kind of helping us get ready for Tuesday's stuff. Is getting that factored form there. That's what we're after. So let's look at one that's maybe a fraction out of that, because those are a little same process, but it seems more difficult because it's got a fraction. So let's take that same polynomial, x to the 4th minus 2x to the 3rd plus 4x squared plus 2x minus 5 is 2x minus 1 a factor. if I set 2x minus 1 equal to 0 and solve that, this is going to tell me what goes on the shelf. One half. Okay. So 1/2. The other way that they could ask that a question is k equals 1/2 a 0? That's the same question out of that. So we're gonna set it up with synthetic division. I'm gonna use 3 lines here because the fractions just take a little bit to write in there. So 1/2 on the top, and then you got 1, -2, 4, 2, -5. Again, if there were a missing piece in this polynomial, you'd put a 0 in its place. Don't forget that. That comes up sometimes. And again, drop the 1 down and then multiply. 1 times 1/2 is 1/2. And I'm just going to use my calculator to help me out here. So I've got a -2 plus 1/2. Math, enter. -3/2. And then I'm multiplying -3/2 times 1/2. -3/2 times 1/2. -0.75. I think that's -3/4, but I'm gonna hit math, enter just to make sure. -3/4. 4 plus -3/4 plus -3/4. Math, enter. 13/4. So same process, but the fractions just kind of make it a little bit tougher to deal with. And then we're going to multiply 13/4 times 1/2. 13/8. 2 plus 13/8. Math, enter. 29/8. 29/8 times 1/2. Math, enter. 29/16. So we can tell right now that that's not going to be a 0 there, but I'm going to go ahead and get that number. -5 plus 29/16. Math, enter. -51/16. That's what that is. -51/16. Not a factor. You might see that written by some folks as x minus 1/2 x to the 3rd power minus 3/2x squared plus 13/4x plus 29/8 and then minus 51/16. That's also a way of writing that. The main thing is knowing that that's not a factor because the remainder is not 0. Remainder has to be 0 for that to be a factor or for the number to be an x-intercept for that. Okay. All right. Last thing that we'll talk about here is what if it's a complex number that they want me to check instead of a fraction. Fractions are tough enough. They're going to throw some complex numbers in there because complex numbers can be solutions to quadratics. We saw that on Tuesday. Complex numbers can also be solutions to or x-intercepts for polynomials. that are bigger. So we've got to deal with those, and we deal with those using synthetic division as well. So let's take polynomial x to the fourth minus 2x cubed plus 4x squared plus 2x minus 5. And find out if 1 plus 2i is a 0 of this polynomial. Okay. Generally, they will not ask you to if a quadratic is a factor of it. Straightforward. They'll just ask you. The complex ones will be asked in this method. Okay. We'll have the other question for that. So let's set it up synthetic division wise. You got to give yourself plenty of room here because you got to write some complex numbers in there. We're going to use the calculator to help us do the complex number operations. So very, very important that we did that earlier on. So it's kind of a big deal to be able to do that. It's going to help us. So I've got 1 plus 2i on the shelf. 1, negative 2, 4, 2, and negative 5. I'm just giving myself extra room here. Just spreading it out. Okay. Process is exactly the same. Drop the number down and then multiply. 1 times 1 plus 2i. That should be 1 plus 2i. Okay. And then you're going to add the same process. Nothing is changing about the process. So we're going to take negative 2 plus 1 plus 2i. So I just use my calculator to type in that complex number. 1 plus 2, and then to get the I, remember it's second decimal point. And I get a negative 1 plus 2i. Makes sense? This is where the calculator really gets handy, is being able to multiply these complex numbers together. Okay? So we have 1 plus 2i times a negative 1 plus 2i. So my calculator, I'll put 1 plus 2, second decimal point for the I. Close that parenthesis, open up another set, negative 1 plus 2, and then second decimal point to get the I. And let it do the work to get negative 5. And that works out nice because I got a number that's not a complex. So 4 plus negative 5 would be negative 1. That's a little easier to do. So again, I'm taking negative 1 times 1 plus 2i. Should just change the signs of those, and it does. So that's negative 1 minus 2i. Calculator, I'm taking 2 plus negative 1 minus 2i. Get 1 minus 2i. Then I'm multiplying 1 plus 2i times 1 minus 2i. Parentheses, 1 plus 2i. Be careful to put those in parentheses. If you don't, it's not going to work. Positive 5. Hey, that's nice. Because that means the remainder is 0. So 1 plus 2i is a 0 of f of x. We won't write this one in factored form just because there's a lot more that's going on that we'll talk about on Tuesday. When you've got one complex solution, there's always a conjugate complex solution that works with that. So if we did synthetic division again out of that. The main goals of today are be able to do circles, write the equation of the circle given the center and a radius, go the other direction given an equation, find the radius and the center. That's the easiest thing we did today. And then the long division, kind of a tough thing. A lot of operations, a lot of places that you could make sign mistakes. You got to be real careful with that. So long division, important skill. We don't use it quite as much to finish up the course, but we will use it again in 110. So make sure you've done some practice with that. And then the main skill of the day is the synthetic division. Make sure you can do that. That's going to be very important on Tuesday when we start using that to solve polynomials. Because solving polynomials, you're trying to break them down, and the synthetic division is going to be helpful in doing that. It's going to make things go much faster for us and give us some options out of that. So I told you we'd be done pretty early today, and we are. So this will give you a little extra time to get some labs and some quizzes done for today's stuff and Tuesday's stuff. So that'll give you a good break, and you get to enjoy the long weekend. And then I'll see you on Tuesday, 9 o'clock. And then remember, next Thursday we will not meet. And then your final will be July the 2nd. Problems that you could look at for this, I forgot to write that up. Let's get it in order here. The last section, page 305, 1 through 57 on. And then the long division section, page 30, 89 through 95 odd. And then the circles is on page 185, just like 1 through 11. Not many questions about circles or long division. Like I said, the main thing today is synthetic division, so make sure you work on that some. Like I said, I'll email you or I'll send out the announcement with the links to the video and which labs and quizzes to do, and I'll also attach your practice final today. And my plan is to get started grading your labs that you've all submitted so far. So, anyway, does anybody have any questions or concerns?